Hey Pre-Calcers, welcome to 4.2. We are going to be taking everything we've seen with trig and now applying it to the unit circle, which you've seen previously with the angles that have worked with it, but you haven't seen the measurements of the xy coordinates for select points, so we'll talk about that. We'll be using the unit circle to define trig functions. I don't think we'll see too much of the domain and range. We'll find exact values for trig functions, not quite of pi over 4. My goal is that we're thinking more in a broad sense of how that will work. And those other ones, I don't know if we'll hit them, but I'm pretty sure we hit these 3. So recall that if you get stuck, think about these, and the examples that we'll look at should show what's going on with them. So use even and odd properties, which we don't really use because we know how to graph this out on the unit circle. We saw that in the previous section. We'll be using that intel to find the value of cosine of negative 11 pi over 6. So if you get stuck at any point in time, chances are you'll need to look back at one of the following. We'll see special right triangles. We'll need trig. What else? We'll need to understand how to map out radians. And also going to degrees. So if you get stuck on anything that's here, please consider looking back at a video or ask a question if you're still not sure what's going on. All right, so cosine of negative 11 pi over 6. This is definitely something we could map out. We could take apart the unit circle and map out into 6s. So let's do that. Let's do this bottom part into 6 setups, or 6 slices rather. That's kind of how I've been thinking of it. You can connect this back up to here. So notice that I'm breaking this apart into 6 slices for the bottom and the top. And recall that this would be 6 pi over 6. This would be pi over 6. This would be 2 pi over 6. 3 pi over 6, or pi over 2. But since it's mentioning denominator of 6, we're going to keep going in 6s. So let's go past 1, 2, 3, 4, 5, 6. 7, 8, 9, 10, 11. So we've hit this negative 11 pi over 6. And so we're really going to break apart this triangle that's created here. So whenever we hit the angle, which we did, we start to make a triangle that goes off of this, I guess you could call this the x-axis, and we'll work just off of that. So if we focus in just on this triangle here, what do you think this angle here is going to have to be? If you divvy up 90 degrees into 3, each of these slices should be 30 degrees, and that's the case here. So this is 30 degrees. Up here will have to be 60 degrees. Recall that since we're dealing with a special right triangle, you'll want to have these on hand, so maybe recopy these if you need to. Recall that across from 30 is our smallest side. Across from 60 is square root of 3 times the smallest side. Across from 90 is 2 versions of the smallest side. And the reason that we're focusing in on the 30, 60, 90 is because the triangle that we've created is a 30, 60, 90. Because the leftover angle from here to here is 30 degrees. So this will have to be 60. This will have to be root 2. All right, so this might be a good opportunity for you to break apart from the unit circle and just focus on the triangle itself. Where, if you recall, the hypotenuse is 1, because that's standard for the unit circle. And if we look at our side lengths, this part can be a little tricky, but we refer to the smallest side as here. And we will refer to the smallest side as 1/2. So the smallest side's 1/2. This is across from 30 degrees. So ideally, across from 60 degrees, this is s root 3. So this should be square root of 3 over 2. Okay, well, recall that we're trying to find cosine, which is r adjacent over r hypotenuse. If we're in this angle here, because recall we're working out of this angle, what's adjacent to 30 degrees? Should be saying square root of 3 over 2. So we can say that this is square root of 3 over 2 over 1. And then we can just simplify this to square root of 3 over 2. Done. So this would be considered the cosine of a negative 11 pi over 6. Positive square root of 3 over 2. Done. Let's keep this going. Maybe pause the video, look back at what you just saw, because this just gets more difficult. All right, so we have this point P at 3/5, comma negative 4/5 on the unit circle corresponding to a number t. Find the values of the trigonometric functions at t. I'm first going to draw this out. So let's do that. So we have a positive x coordinate. So this is positive, but our y coordinate's negative. So drawing that out may be helpful. So draw this triangle like so. Positive x direction, negative y direction. This is 3/5, this is negative 4/5. And we're finding the values of the trig functions at t, which is here. This makes a right angle. If we use Pythagorean theorem to get a hold of our hypotenuse, that should be, what, 9? I think it's just going to be 1. Yeah, it's got to be 1. Because you get 3 over 5 being squared. You're adding on negative 4 over 5 being squared. And that should be equal to our hypotenuse being squared. That's 9 over 25. That's 16 over 25. Yeah, so our hypotenuse is 1. All right, so you remember all those trig functions. Let's do this. Sine of t is going to be our opposite. So that's negative 4/5 over 1, which you can just write as negative 4/5. I'm going to do that in this case because anything divided by 1 is just itself. Cosine of t is just 3/5 because that's our adjacent. Tangent, a little bit tricky here. So opposite is negative 4/5, and we're dividing that with 3/5. If we rewrite this, negative 4/5 times 5 over 3, 5's cancel, this is negative 4/3. So that's for tangent, that's for cosine, that's sine. We also saw the additional trig functions, or we should be seeing them, where cosecant is sine but flipped. So that's equal to negative 5 over 4. Secant should be equal to 5/3, because we're just flipping sine of t. Cotangent of t is going to be negative 3/4. Boom, we got our 6. Notice that for the y-coordinate, you do have to include that it's negative. That's a really important part. We'll take this further using theta as an acute angle and cosine of theta as square root of 31 over 9. Use the Pythagorean identity sine squared plus cosine squared equals 1 to find sine of theta. Sure, we know cosine squared should be square root of 31 over 9 being squared. This should be equal to 1. Square root of 31 times square root of 31 is just 31. So this should be 31 over 9 squared, which is 81. 1 we should consider rewriting as 81 over 81. Sorry, I'm kind of dodging writing the rest of this. And then if I deduct 31 over 81, this should be equal to sine squared of theta equals 50 over 81. If we take a square root on both sides, sine of theta just on its own should be equal to, well, this can be broken down further, because 50 has 25 as a factor. Square root of 81 is just 9. So sine of theta, if we break this down even further, square root of 25 is 5. Root 2 is along for the ride. This is all over 9. We're done. Sorry, this video was longer than the other ones we've seen. I know that there was a lot here, but if you have questions, please let me know. Thanks for watching.